All right, we're going to go ahead and get started. We don't have a ton to do today, but we are going to finish up the polar coordinate notes. I'm going to go ahead and give you the homework assignment. The key is already posted to the website because you have a couple of days now before the break starts. And let me go ahead and show you this. Okay, you're also going to have an additional day after the break starts, so the assignment isn't going to be due until Tuesday, December 2nd. Okay, so that gives you a couple of days before, one day after, so you don't necessarily have to work on it through the break. I would prefer you go ahead, take some time off, relax, come back ready to go ahead and finish up the second semester. Okay, but it'll be due on Tuesday, and then Wednesday after that we'll have a quiz over the polar coordinates. Okay, and then the remainder of this week, every other class period, we're going to be looking at how to graph polar functions. Okay, the graphs themselves. Okay, so questions on that? Okay, well, if you'll look at the last page of your packet here, you remember back in geometry when you were plotting points in a rectangular plane? Caroline, it says when convenient. So, but you're about to go to that assembly too, right? I might just go ahead and go take a look at this. Yes. Okay, so you know when you go ahead and plot points in a rectangular coordinate system, you found the distance between those two, the square root of x2 minus x1 squared plus y2 minus y1 squared. Does that sound familiar? Okay, well now that we're plotting points in a polar coordinate grid, we're going to use a formula to find the distance between them. Okay.
Pardon the interruption. Seniors, at this time, or for this auditorium,
Okay, so that is Caleb, Oliver, Lexi, and Carolina. Yes, and you're going to the other place. Okay. So just be looking at the notes. Come on in if you have questions, but this video link will be posted later today. All right, so we're going to go ahead. Here's the formula. So everything's below the square root. The first radius squared plus the second radius squared minus 2 times the first radius times the second radius times cosine of theta 2 minus theta 1, the difference of your angles. Okay, so what's really nice about this is you just have to substitute into your formula, and then we're going to let the calculator do the heavy lifting for us. Now, we are going to go ahead and at least find the difference of the angles ourselves. This formula can work with both degrees and radians, but since we want to be as comfortable as possible with radians, we're going to go ahead and opt to use those. Okay, so let's say that this is the first radius and the first angle, second radius and the second angle. So first thing I'm going to do is subtract my angles, 7 pi over 4 minus pi over 3. And what's my common denominator? 12. Okay, so I got to multiply this by 3 over 3, 4 over 4. So it looks like I'm getting a 21 pi over 12 minus a 4 pi over 12. So it looks like the difference of my angles is going to be a 17 pi over 12. Okay, we've already got each radius. All we have to do is substitute in. So our distance is going to equal the first radius squared, 2 squared, plus the second radius squared, 3 squared, that's 2, and then minus 2 times the first radius times the second radius times the cosine of that 17 pi over 12. And all of this is below the square root. And as you substitute in, 2 squared 4, 3 squared 9, if you want to go ahead and start to simplify the radicand, you're more than welcome to do that. Okay, but we're going to round these distances to the nearest hundredth. So let's come on over here to the calculator. So control x squared is going to give me the radical. So 2 squared 4 plus the 3 squared 9 minus 2 times 3 times the cosine of 17 pi over 12. Okay. And if we're going to choose to work with radians, make sure that your calculator is in radians. But when I go ahead and push enter, I should see the distance between these polar points is 4.01 units. Okay, so part of this is being able to input it in the calculator. Did anybody get anything different? Okay, so 4.01 units. Come on, back over here. Okay, that's it. That's all there is to it. Let's try another one of these. Because number 7 brings up a good point that I want to make. So we've got my first radius and first angle, second radius, second angle. They're already in radians, so I'm going to take the second angle 2 pi over 3, and I'm going to subtract the first angle 11 pi over 6. So the common denominator here is going to be 6. So I'll multiply this by 2 over 2, which gives me a 4 pi over 6 minus 11 pi over 6. So it looks like my difference is what? Negative 7 pi over 6. Now this brings up a good point. Even if you switch the ordered pairs, okay, like we did on number 6, if we switch them, we would have gotten a negative difference there. But when you plug it into the formula, it doesn't matter whether your difference is positive or negative. Okay, what about cosine makes that true? Oh, no, I'm thinking about an identity. Do we remember an identity if, say, cosine has a negative angle? Cosine of negative theta would equal what? Cosine of theta, because it was an even function. Okay. So whether you substitute in a negative or a positive angle, you're still going to be able to get the same answer. That changes nothing. Okay, so now we just substitute. So I've got the distance equals first radius squared plus the second radius squared minus 2 times the first radius times the second radius times the cosine of negative 7 pi over 6. And then all of this is below the radical. Okay. And this time I'll actually put in the negative just to show you that it doesn't matter. If you want to put in just 7 pi over 6, you're good. Okay, but everybody go ahead and type this in and let's see if we match up. So I'm going to take a shortcut. The 1 squared plus the 5 squared is going to give me 26. So I'm going to come on over here, the square root of 26 minus 2 times that negative 1 times 5 times the cosine, control divide, of that negative 7 pi over 6. Okay, so who can help me out? What distance am I going to find when I push enter? Anybody? What we get? 4.16. Yes. 4.16 units. There we go. Anybody having a hard time? Okay. All right. Come on back over here. 4.16 units. Okay. So let's go ahead and skip number 8. We've seen that type of problem. They are in degrees, okay? But let's go ahead and take a look at the word problem. The position of 2 ships around an iceberg can be represented by the coordinates 12, 40 degrees and 28, 215 degrees, where the directed distance is measured in miles. Find the distance between the 2 ships. Okay, so you can go ahead and convert each of these immediately and then go ahead and subtract them, but I think that's going to give you more work. Let's just subtract them right now. 215 degrees minus 40 degrees, that's going to be 175 degrees. And yes, remember the formula will work with degrees, but we want to work with radians. In fact, this is a good opportunity to spiral back in that conversion. What am I going to multiply 175 degrees by to get radians? Does anybody remember? It's been a while. Pi over 180. There you go. Okay, absolutely right. Because the first thing you got to cancel out are going to be the degree symbols, and then you go from there. So each of these has a common factor of 5, so we're looking at 35 pi over 36. But remember, you're plugging this in the calculator, so even if you didn't simplify it, if you plugged in 175 pi over 180, the calculator is still going to give you the answer you're looking for. Okay. So go ahead and plug that into the formula. You've got your difference of your two angles. You've got your radius. Let's see what you can get for the distance. So we're looking for miles in this case. How many miles are a part of the two ships? So while you folks are finishing that up, I'm kind of curious how many of you are going to go into your Thanksgiving break being thankful that you do have pre-calculator. So that's what I thought. I appreciate it. Okay, remember, you have time before and after the break, so you don't necessarily have to do it during the break. Okay, are we about ready? We're going to round this to 2 decimal places as well. Everybody ready, or we need a few more seconds? Okay. I got 39.96 miles apart. Okay. How many people got that? Okay. Would anybody like me to plug it in the calculator? Plug it in? Okay. So we've got 12 and 28. Okay. So I'm going to come on over here. Let's see here. So 12 squared plus 28 squared minus 2 times 12 times 28. Okay. Times the cosine of, we need 35 pi. That is not what I need. I need that, 35 pi over 36. Okay. So there's my 39 point. Oh, that one's 97. Oh, I'm sorry. I was off by a 0.01. All right. But there we go. Questions. Okay. So the only trick to these is just going to be if they ask you something like this on the AP exam, being able to recall that formula. That's going to be the only thing. All right. Let's switch gears a little bit. Final page of our notes. Let's go ahead and talk about the complex plane. Okay, so we're going to kind of expand on what you would have done back in Algebra 2 and kind of tie it in with our polar coordinates. Okay, so recall that the standard form of a complex number that we're going to call z is a plus bi. Remember, a is the real portion, bi is the imaginary portion. So let x equal a and b equal y. So we're just going to replace those because we're working with rectangular points. Okay, make that our new complex number. So a point is plotted in the complex plane using the horizontal axis as the real axis, and the vertical axis is your imaginary. Now, the first example, it says plot the complex number 2 minus 3i on the complex plane shown at the right. Now, remember, the a and the b, we replaced those with x and y. So the same way I would plot the point 2 comma negative 3 is exactly how I'm going to go ahead and plot this complex number. From the origin, I'm going to go 2 to the right, and then we have negative 3i, so I'm going to go 3 down. So that point, there we go, would be right here. So you have in a complex plane a horizontal axis and the imaginary axis. Now the modulus or magnitude of z, denoted by the absolute value, is defined as the distance from the origin to that point. So if I connect these right here, it makes sense why we're going to be using the square root of x squared plus y squared, because if I go ahead and connect the origin through the path that we took, see, it creates a right triangle. You've got x and y. We're going to go ahead and call that z. So x squared plus y squared equals z squared. We're just modifying the Pythagorean theorem. Okay. Now, engineers often use polar form to represent complex numbers rather than rectangular form. So to write a complex number in a polar form, we're going to use these identities that we're already familiar with. X equals the radius times cosine of theta, and y equals the radius times sine of theta. Okay. Now, after substitution, we arrive in the polar form of a complex number. So this is how we identified a complex number a moment ago, x plus yi. So you'll notice I'm simply replacing x with the r cosine theta and y with the r sine of theta. So that's how we're getting the polar form of a complex number. Now, the only difference between these two is that in the second one, they decided to factor the radius out. Okay? So whether you want to distribute the radius or factor it out, that is completely your choice. Now, in this form, the radius r, okay, and theta between 0 and 2 pi is called the argument of z. R is the radius, and theta is called the argument of z. Okay. All right. Everybody had a chance to copy that? Okay. All right, let's work some examples. So example 10, it says plot the point corresponding to z equals -3 plus square root of 3i in the complex plane, and write an expression for z in polar form. Now, when it's talking about the polar form, remember, it wants this that we were just looking at, the polar form of a complex number. So that r sine theta, r cosine theta plus r sine theta I. Okay, here we went. Yesterday, do you have your batch? Okay. All right. So all I need is the radius and my angle theta, and we'll have everything we need. So I'm looking over here. Remember, can anybody tell me what x is from -3 plus square root of 3i? Okay, what's x? -3. And y would be the square root of 3. Now, I want to go ahead and plot this point, and you can confirm this in the calculator, but the square root of 3 is going to be roughly 1.73. Okay, so from the origin, I'm going to go 3 left, and then kind of estimate where I would have 1.73. Okay, right there. So our point's in quadrant 2. Now, we're building off what we did yesterday. See, we have an x and a y, but we need to use that to find a polar coordinate. Okay, so the first thing we're going to do, that radius, the distance from the point to the origin, we're going to take the square root of x squared plus y squared. Now, remember, a moment ago, they referred to this as z, but it's not going to change anything if we use this variable that we're already accustomed to. Okay, so the radius is going to equal, so we're going to have x squared, so a -3 squared, plus the square root of 3 squared, all below the square root. So it looks like I'm going to get the square root of 9 plus 3, so the square root of 12. So what would that be if I simplified it? Actually, what do you think? Square root of 12 simplified. 2 square root of 3. So there's my radius. Okay, so I know that the distance this point is from the origin is 2 square root of 3 units. Now we need to go ahead and find the angle theta. Remember, because we have x and y, yesterday we were using tangent. Okay, specifically, we were using this. Tangent of theta equals y over x. So I'm going to go ahead and substitute in. Remember, we have the x and the y right here. So tangent of theta is going to equal. So we're going to have a negative square root of 3 divided by 3. So there's your y divided by x. And of course, to find theta, we have to take the inverse. So tangent inverse of a negative root 3 over 3. Okay. So is everybody okay with what I'm doing so far? Okay. Let's see here. Emmanuel, quadrant 1 or quadrant 4? Quadrant 1 or quadrant 4? 4. Okay, yes, because it's a negative ratio. So I'm going to draw my triangle right here. Okay, we've got y over x, so this would be a negative root 3. This one right here would be 3. And if you were to apply the Pythagorean theorem, that hypotenuse is going to be 2 square root of 3. Exactly what we already found. Okay, everybody okay so far? Anybody want me to, well, we don't need to prove it because we actually just did it. But what kind of triangle is this? This is a 30, 60, 90. So what's this reference angle right here? Would that be 30 or would that be 60? That would be 30. Yeah, remember the smallest angle has to be opposite the shortest side. And we have to rotate clockwise to get to that hypotenuse. So 30 is going to be pi over 6. So I'm going to go ahead and say that theta is equal to a negative pi over 6 radians. Everybody okay? Remember, this is what we were doing yesterday. We're just now throwing in this little portion of the complex numbers. So let's take what we have. We found the radius to be 2 square root of 3. And we found our theta to be a negative pi over 6. Okay. Now, before we go ahead and write this in polar form, we've got a problem. Anybody tell me what that is? Okay, where was your original point? Where was that 3 minus root 3i? Or excuse me, negative 3 plus 3, root 3i. It's in quadrant 2, right? What quadrant is this point? It's in quadrant 4. So I can't use this one to go ahead and write my final answer. Okay, so we got to ensure that this polar coordinate is in the right quadrant. Now, there is an easy fix. We could just go ahead and make the radius negative, which would take this point in quadrant 4 and push it into the quadrant we want. But let's say we want to make sure that the radius stays positive. Remember something we did to help fix this yesterday? Let's take the hypotenuse. So this would be the point that we have right here. Okay, this point. Okay, because we have 2 square root of 3, we have the negative pi over 6. Let's say I take this hypotenuse and I go ahead and extend it into the other quadrant. So that this new segment, that's also 2 square root of 3 units. All we need is the angle that would get me there. Remember yesterday I mentioned vertical angles. If this is 30, then this is 30 right here. So how far would I have rotated from standard position to get to that segment? 100 and what? 150. So what I'm looking at here, 150 degrees, see that would be 5 pi over 6. This is in quadrant 2. This is the one I'm going to use to write my final answer. Is everybody okay with that? Okay. All right. Now, a little higher up on your page, remember, you've got the form for the complex number of a polar coordinate. Okay. Remember, that was r cosine of theta plus r sine of theta times I. Well, we have a radius and a theta right now. So I'm going to say 2 square root of 3 cosine of 5 pi over 6 plus 2 square root of 3 times the sine of 5 pi over 6 I. So there's the polar form of the complex number. And I wrote it with the 2 root 3 distributed. Remember, you can factor that out if you want to. Not a problem. And there we go. Anybody having a hard time? Anybody got questions? Well, for number 11, let's say we want to reverse that. So they're going to give me this polar form of a complex number, and I want to rewrite it in rectangular form. Okay, so let me go ahead and get rid of all this right here. Remember, rectangular form for the complex number, we want to rewrite it as x minus yi. So this one here, there's a lot less work. All I need to do is just go ahead and evaluate. We need to know what cosine and sine of 11 pi over 6 is going to be. We already know that the radius is 2. Okay. So 11 pi over 6 is going to be in quadrant 4. Okay, so let's say this right here is 11 pi over 6. So would everybody agree that my reference angle is pi over 6? Okay. So let's say we're on the unit circle. Well, across from 30 degrees, remember that was 1/2. Across from 60 was the square root of 3 over 2. Okay. Always make sure you know what quadrant you're in. Oh, thank you. So let's see here. I've now got 2 times. What is the cosine of 11 pi over 6? What am I getting from my picture? Mason, what's my cosine of 11 pi over 6? What's the x length in my triangle? Okay. It's over 2. Remember, what's the x value of my triangle? Or cosine is the x. Square root of 3 over 2. Plus I times, let's see here. Rami, what is sine of 11 pi over 6? Remember, sine is the y variable. Oh, that's tangent. Don't know. Okay. Enrique, can you help him out? The 1/2. Okay. That's okay. It's okay. All right. And now all I have to do is distribute. Okay. So 2 times a root 3 over 2, that's going to give me root 3. And then 2 times I times a negative 1/2, that's going to give me minus I. So see, I was able to get back to the rectangular form of the complex number. All right, there we go. So we are done with the polar coordinates lesson. Questions? Now, one thing very quickly, I knew that you folks were about to go 10 days without math, and that probably starting on Monday or Tuesday, you'd be climbing the walls, where's my pre-cal? So I got a little fix for you right here. I've got 2 problems from this section that are College Board problems. Okay, I want to give you a few minutes to take a look at this, and let's see, based on what we just said, can you answer these questions? Okay, so I'm going to give you 4 minutes, 2 minutes for each problem. Take a look at these. Let's see if you can figure those out. While you're doing that, I am going to erase and get set up for the next class. Is everything okay? Sarvesh, what happened? Oh, okay. Yes. Yes. And remember, this is something I've mentioned before, especially when it comes to the College Board problems. Okay, you're going to have 40 multiple choice questions on the AP exam. Use the answer choices to your advantage. And I'll show you what I mean by that in these types of problems in just a moment. 20 seconds. Okay, so you may not be done, and that's okay. All right, so this first one says, what are the rectangular coordinates x, y that give the location of the point with polar coordinates 2, comma, negative 7, 6 pi? Well, you remember what I said about using the answer choices to help you. What quadrant is that polar coordinate in? Not 4. It is quadrant 2. Okay, it's in quadrant 2. So that means the point I choose has to be in quadrant 2 as well. So in a rectangular system, it's got to have a negative x and a positive y. See, that automatically eliminates A and C. I haven't even done any work yet. And I've already eliminated half the answers. Okay. Now remember, for this particular type of problem, what we did was used x equals r cosine of theta, and y is equal to r sine of theta. Okay, so let's see what we got here. R cosine of theta, well, the radius is 2 times the cosine of a negative 7 pi over 6. All right, so let's see what we got here. So negative 7, 6 pi would rotate around to about right here. Okay, so negative 7 pi over 6. Okay. Let's go ahead and do this on the unit circle. Now, I know we have a radius of 2, but if we always default back to the unit circle, it's still going to work, even if you use the radius given. Okay. So would everybody agree that this reference angle is pi over 6, which is 30 degrees? So 1/2 is across. Remember, we just saw this triangle. That means the other leg has got to be a negative root 3 over 2. So here's x, here's y, here's r. What's the cosine of negative 7 pi over 6? Negative square root of 3 over 2. So 2 times the negative root 3 over 2 is going to give me a negative root 3. This is also another thing. You don't always have to finish the problem. Okay? Like, I know this has to be my x value, so that eliminates b. The only answer left is d. Don't always have to finish the problem. That is not always necessary. Sometimes you do, sometimes you don't. Depends on the answer choices they give you. Okay. How many people got that first one? Okay, that's not bad. Not bad. Okay, let's take a look at the second one here. Now, the figure shows point P in the complex plane. Which of the following complex numbers corresponds to the location of P? Okay. Well, we can definitely see that P is in what quadrant? Okay, it's in 4. What answer can I eliminate? A. Okay. This complex number would actually be in quadrant 2. Now, this one I was only able to eliminate 1, but now at the very least I still have a 1 in 3 probability instead of a 1 in 4. I've slightly increased my chances. Okay. So we're going to use this because they've already given me a radius and they've given me my angle theta. So I know that r times the cosine of theta plus r times the sine of theta I. We can plug in here and simplify. And there is also another way. I can actually use the diagram itself to help me out. Okay, so I can show you both ways. I can show you just one. What would you folks like? Okay, you want me to show you both ways? Let's do it. Okay. So my radius is 3, and the angle provided is a negative pi over 3. So negative pi over 3 plus 3 times the sine of a negative pi over 3 times I. Okay. So we're definitely in the 4th quadrant. So there's pi over 3. I'm going to use that to create a right triangle. So this is 60 degrees. That means square root of 3 over 2 is across from it. 1/2 is here, and the radius is 1. Now, the other way, I'm actually going to use the radius that I was given. So we'll get there in just a second. I just want to make this negative because we're in the 4th quadrant. Okay. Well, let's see here. Cosine of negative pi over 3. Would everybody agree that's a half? Plus 3 times sine of this angle. That's a negative root 3 over 2i. Okay. Well, which answer is looking like what it's going to be? So 3 times a half will give me 3 halves minus. I don't even need to continue. What's the only answer that starts with 3 halves? C. Hello. All right, so that was one way we could have done it, and you would have gotten negative 3 root 3 over 2 here. Okay. Now, let's say you didn't want to go ahead and use that little formula right there. Let's actually use their diagram. Let's go ahead and use that to create a right triangle. Now, we already know that this is a 30, 60, 90. Okay, so this right here has to be 60. Now, remember, we know that this would be x. This would be x times the square root of 3, and this would be 2x. Okay. So whatever I doubled, I got 3. So that means that my shorter leg has to be 3 halves. See, I took half of that. And then I got to take x and multiply it by the square root of 3. So that would give me 3 square root of 3 over 2. See, there's your other value. You could have worked directly from the diagram and gotten your 2 values. Okay. So how many people got both of those right? Okay, good, good, good. Remember, don't let College Board intimidate you. Okay. All right, and with that, we are done. We won't be doing any more math until December.